to everyone and welcome to today's tutorial. Before us here is a question on limits. The question says limiting function of this as x tends to 0 sine 3x all over 4x, all over sine 4x rather. So recall in trigonometric identity for limits for sine x, we have limiting value as x tends to 0 of sine x over what? X is equal to what? 1. So whatever we are going to work here, we are going to make sure that everything looks like this. So that is our transformation. But there is another method that is very easy and was straightforward. That is what? Hospital's rule. I don't want to use that. I will use that in my next video. So let's use algebraic manipulation. So this point, you can have, it will now become limits as s tends to 0. Then here, this can be written as sine 3x rather, sine 3x times 1 all over sine 4x. So this can be written as this. You can rewrite it like this. So now let's go further. I want to make sure that at the end of the day, I am going to have something like this. I also have this one to become like this. That's my major interest here. So how do I do now? I have to come here. This one can also be written as what? Limit s tends to 0 of this function. I will have sine 3x times 1 all over sine 4x times 1. Yes, times 1. At the end of the day, you still have the same thing. So there is something I'm going to do. This one here can be also written as what? X over what? X. S over S is the same thing as equal to what? 1. So my major interest is to transform this to become like this. That is what I was working towards. So we go further by saying your limiting function as S tends to 0. Then we then have what? Sine 3x times 1 over what? Sine 4x times x over what? X. So now this becomes like this, because this one that is here, I what? Replace it with this what? X over x. So x over x is sitting as 1. X cancel x is what? 1. So let us transform now. Since all these ones are multiplying this, so at the end of the day, I am going to bring this one here. This is sitting as what? Sine 3x over 1 here. Then we have what? 1 over what? Sine 4x here. So what I'm going to do now, I will take this x here to come here. So I want to rearrange everything to become limit s tends to what? 0 of this function. I don't know, I'm going to have a sine 3s all over, I will bring this s here, then times, at the end of the day, I am going to have x over what? X over what? Sine 4x. So we are going. So let's continue from the other side. Here, it will now become limits as s tends to 0. We already have sine 3x all over what? X. Then it will now give us what? Times. Look at, we already have x over this. So I want to make sure that this x comes down. I want this x to come down. So what do I have to do? In order for this x to come down to look like this, so I have to take reciprocal of this. So taking reciprocal of that, it will now become what? 1 all over what? So taking that reciprocal now, it means for this s we have to come down, then this one will go up. So it will now give me equal to 1 over what? Sine 4s all over what? X. That is what happened here. So to transform this now, to make sure that what, it takes this form of what is our general what sign, to take this general identity. So to do that, we have to take reciprocal so that this sign 4s will come up. So at this point now, you can carry out what another what manipulation. What do I have to do? I want to make sure that this s now must have this 3x. Yes. So that at the end of the day, we can quickly use this identity. If you look at this identity here, you only have what? The coefficient must be the same. The coefficient of s here must be the same. So like here, that the coefficient of s is not the same. Look at it there. So what do I have to do? For me to make this one the same, I will have to what? Multiply up and down. Multiply up and down by what? 3. Multiply down also what? By 3. Then here, I will multiply here, this denominator here. The up and down of this what? Second denominator, right? I will multiply it what? By 4. Up and down. So at the end of the day, I am going to have what? Your limiting function of what? S tends to what? 0. Then I will have here sine 3x all over x, then times 3 over what? 3. Multiply. I'm trying to minimize the board. So multiply by 3 over what? 3. Then we have here, the next one is what? 1 all over sine 4x all over s. So this denominator here, also multiply it by what? Multiply it by what? This coefficient of s here, which is what? 4 over what? 4. So at the end of the day, I am going to have your limiting function of what? S tends to 0 here. Then here becomes what? 3 sine 3x all over what? 3x. Then times 1 all over where? This 4 multiply this sine 4x become 4 sine 4x. Then all over 4x. Now, open the limit of both sides. 3 sine 3x all over this s tends to 0 all over 3x times, that's a limit of what? S tends to 0, then 4 sine 4x all over 4x. Remember, this is what? 1 all over. It's 1 all over there. So that it is reciprocal. Don't forget, there's 1 all over there. So let us go further. So we say let y equal to 3x, then and what? Let's say k equal to what? 4x. So that means that what? Here now, I will now have what? Limit now. Then this side now will no longer take s again, since we say let y equal to, we are changing it to what? Y function, because y tends to what? 0. We now have a 3 sine what? The whole of this 3s now becomes what? Y. All over what? Y. Then equal to, okay, yeah, no, times 1 all over. We say that of sine 4x here, we say let k equal to what? 4x. So now become equal to what? Your, okay, times limit of what? 1, that is 1 all over 4 sine k. Now here this one becomes what? K tends to 0 now. It's no longer what? 4s anymore. So all over what? K. So we have been able to come to the general identity. So where we buy the whole of this one now, these 3 can come outside to become 3 limit of y tends towards 0 sine y over what? Y. Then times this 1 over this thing, 4 can come out here. So I don't know, they become what? 1 all over 4. That is 4 limit of sine k all over k. So remember, k tends to what? 0. So here now we have come to this identity that says what? Limit of s tends to 0. We have a sine s all over s, which is equal to 1. So at this point now, the whole of this place now, the limit of this sine y all over y is what? Is what? 1. So at the end of the day, we have what? Here become what? This one now become 3 times 1. then times, here we have 1 all over the limit of all these ones, because 1 all over, then limit of sine k all over k is setting as equal to 1, become what, 4 times 1. So which means we have what, 3 times what, 1 over what, 4. So my final answer become what, 3 over what, 4. So this process is rather long and is quite rigorous. So what I will advise you is to use a hospital's rule. Hospital rules, you don't have to go to this length. So this is the end of the class. So if you find this class very interesting, please do not hesitate to share this video. God bless you.